How does that help us in artificial intelligence? That's what's going on in a brain in a very hand-wavy way. Okay, so that's obviously not a technical explanation of what's going on. How does that help us in neural networks? Well, we can implement that stuff in software. The idea goes back to the 1940s and two researchers, McCulloch and Pitts, and they are struck by the idea that the structures that you see in the brain look a bit like electrical circuits. And they thought, could we implement all that stuff in electrical circuits? Now, they didn't have the wherewithal to be able to do that, but the idea stuck. The idea's been around since the 1940s. It began to be seriously looked at, the idea of doing this in software, in the 1960s, and then there was another flutter of interest in the 1980s, but it was only this century that it really became possible. And why did it become possible? For three reasons. There were some scientific advances, what's called deep learning. There was the availability of big data, and you need data to be able to configure these neural networks. And finally, to configure these neural networks so that they can recognize Turing's picture, you need lots of computer power. And computer power became very cheap this century. So we're in the age of big data, we're in the age of very cheap computer power, and those were the ingredients, just as much as the scientific developments, that made AI plausible this century, in particular taking off around about 2005. Okay, so how do you actually train a neural network? If you show it a picture of Alan Turing and the output text Alan Turing, what does the training actually look like? Well, what you have to do is you have to adjust the network.